Okay, so we have just talked about the concept of switching, and we have mentioned MAC learning and applying MACs in the MAC table. This is some brief information about the MAC table. It is filled as a table. This is the MAC table. It is filled, or MACs are learned based on the source MAC of the port. This is called the dynamic entry method. So I have a table with the MAC address. This is the dynamic method type, and the ports. Leave this colon to the upcoming video. Okay, so I do learn the source MAC address, that port gigabit ethernet 02 will lead me to this MAC address, because this MAC address is sourced from this interface. This is how the MAC table is filled. The decision of switching is taken based on the destination MAC. Okay, so this is a switch and it is connected to two PCs. Okay, so when this switch receives the frame from PC number 1, which is gigabit ethernet 01, requesting it to receive or deliver this frame, deliver this frame to PC number 2, which is connected to port gigabit ethernet 02. Okay, so switching is based on the destination MAC, because PC number 1 said that it want to talk or communicate with this MAC address. So where does this MAC address is sourced from? Where is this MAC address sourced from? It is sourced from gigabit ethernet 02. So I will switch this frame to gigabit ethernet 02. Okay, so this is how the MAC address table is filled. Now the dynamic entry decision is taken. There is something called aging time. You know this MAC table, maybe me as a switch. Okay, I'm not switch. Let me draw this switch and connect it to multiple devices. These are end devices. They might be computers, they might be what, routers at all. They might be computers, servers, IP cameras, printers, IP phones, a lot of options. Okay, WLANs, we will talk about this later. Okay, WLAN access point, I mean. Okay, so this is the switch in the office that you work with, or you work in, I'm sorry. Every day you have some employees come to work, maybe in the morning, maybe at 8 a.m. Okay, this depends on your network policy, your company policy. Okay, what they do as employees, that they plug their computers in the switch of the office to obtain two things. First of all, access to the network to do their job. The second thing, which is optional, the internet. Okay, so what do happen in this switch? This switch has a MAC table. This is the port, and this is the MAC address for each end device. Okay, so this should be normal behavior. These are about 10 devices, so I have 10 fields filled in here. How much are these? 4, 5, 6, 7, 8, 9, 10. Good. Okay, with their MAC addresses. Maybe by the time that this shift job or this shift duty is over, maybe 8 hours after that, those employees will leave the office. Other employees will come to the office and they will connect, maybe other 10 employees will connect their 10 computers to the same switch to obtain the same two things that we have just talked about, the access and the internet. These are 10 new entries added in the switch. Okay, now they become 20. Maybe after 8 hours, the day hasn't finished yet. Maybe this company works for 24 hours, maybe not. A third shift maybe comes, 5 or 10 MAC addresses are added. This will increase the MAC addresses, the information, the dynamic entries inside the MAC table. Until now we are good, but you need to know something. the maximum limit of the Cisco switch to memorize or to dynamically memorize and insert MACs and their ports inside a MAC address are 300 MACs, not MACs, I mean MACs. Okay, so 300 MAC address is the maximum number of MAC addresses that a switch can endure inside its MAC address table. What happens? Why it's 300? Why it's not more? Because switches, routers are just normal devices. Just like we have talked in chapter 1, they have random access memory, they have a processor, they have a hard disk drive, they have a flash memory. You will get to know something that is called the NVRAM in the switches and routers in the Cisco devices components. Okay, so when you exceed 300 max, maybe you will reach 500 or 1000 mac, the memory will be full. And when it becomes full, when a switch memory becomes full, when its MAC address table gets full, the switch will no longer, the lookup engine will no longer behave correctly. So the switch will behave like an old device, an old layer 1 device that was called a hub. A hub doesn't use CSMA over CD, doesn't have a lookup engine, so collision will happen. Okay, collision will happen because we have exceeded the maximum MAC entry allowed for us, caused the lookup engine to behave incorrectly. After that, your precious and expensive switch became suddenly a hub, which is a layer 1 technology. A hub doesn't work, you have CSMA over CD, also it doesn't have or uses the lookup engine. Okay, so this is a problem. In order to maintain this, okay, how do I know? Should I just watch or monitor my switch and how much MAC does it have? And when it reaches 300 MAC, what should I do? Should I apologize from the employees? Please, no one replug its computer. No. Should I manually delete the old Macs and in order to maintain the number of 300 and never reach this number, this threshold of 300 Mac entries? No, it's automatic. With Cisco switches, it's automatic. What will happen is that we have an aging time. An aging time is a timer that is assigned for each MAC address entry that gets dynamically assigned in the MAC address table. Okay, at the hour 8 a.m. and the minute, maybe minute 1, okay, and the second 15, the first computer has plugged its Ethernet cable to the network and assigned its MAC address to the MAC table. So I will start counting after this time. This employee is coming early. Okay, anyway, so I will start a counter at this specific time and count for this employee. Maybe he will not be there for ever. Okay, he will not be there up. Just as a simple example, an employee as an average do works maybe or do plugs its specific computer or specific end device to the switch maybe for 8 hours. Okay, after the 8 hours it will leave. So once it leaves, I should delete its MAC address, its MAC entry from the table, the MAC address table, and that's it. I did maintain my MAC address table. So this will leads us that the MAC address table of a switch will always have fresh and active MAC addresses that are currently really plugged in the network and really accessing and using the network. Okay, so this is done by the aging time. How much? The aging time is 5 minutes. 5 minutes. Cisco will never ask about minutes. Multiplied by 60 equals 300 seconds. Every 300 second, okay, the switch will check the aging time. Every MAC addresses that are not active anymore, it will be automatically deleted and removed from the MAC address entry, so only the active MAC address will be available and will still installed in the MAC address table. Okay, so this is the aging time, the cause of the aging time, and it will happen how often? Every 300 seconds. What will happen if the destination MAC address is unknown? This is another thing to talk about. Let me just explain it. 1 minute. Okay, so this switch is connected to these PCs. This is PC or computer number 1, this is number 2, this is number 3, and this is number 4. Inside this switch there is a MAC address table. These are the MAC addresses and these are the ports. Okay, because of history and previously taken actions between them, a MAC table has been generated. So what I have is maybe 0200 colon A colon AB01, which is on port 01 that leads to PC number 1, 0200 I'm sorry, A colon AB02 for port number 2, and finally 0200 4A's AB03 for port 03. For port number 4, this is a recently established or connected computer to the network, to the switch. It didn't do any previous actions, so it's unknown to the network. So the switch doesn't know this device and doesn't have its MAC address. In the previous scenarios, in the classic scenarios, what happens is when computer number 1 want to talk to computer number 3, it will send the frame will look in this way, the frame to have its, I believe its destination MAC d.mac and the source MAC. There is something in the trailer called frame checksum, and there is the data that the frame contains. This is how a frame looks like, if I'm not mistaken. So these are the most important two things to consider right now for you: the destination MAC address and the source MAC address. When computer number 1 sends a frame, and we have just mentioned that this is a frame, okay, so what does the first two fields contain? The first one contains the destination MAC. Who am I want to talk to? I want to talk to computer number 3, and this is the MAC address of it. So I will take this MAC address dynamically and put it in the destination MAC field. The source MAC address, which is me, computer number 1, and this is my MAC address, so I will put this in here. When the switch receives this frame and the frame says me, this source MAC wants to talk to this destination MAC, it will be easy. The switch will take this frame, switch it to port number 3, and that's it. Computer number 3 did receive the frame. Okay, so just in case someone wanted to talk to some unknown person for any reason, it's unknown. Okay, what will happen is that computer number 2, let me explain it here, will send, this is the frame checksum, the checksum, this is the D data of the frame, this is the destination MAC and the source MAC. Computer number 2 will insert its source MAC in here, but it has no idea about the destination MAC address. Okay, because it's unknown, but I want to talk to it. Okay, how do I want to talk to it? You will understand this in chapter 3 because we will use IP addresses. Me as a person will talk to an IP address, not to a MAC address. Switches do understand MAC addresses. Anyway, when a switch receives such frame, and first it will look up two things: where did it came from, the source MAC address, and whom it's concerning to contact. well, it wants to contact to unknown person, unknown computer. What will the switch do? It will fill this field with ones, all ones. Okay, 48-bit. I believe it was not 48-bit, maybe I think it was either 48, maybe 96-bit. Okay, of ones. Okay, this is the conversion between the hexadecimal. You know, the MAC addresses are in hexadecimal, and we are talking about binary. Okay, so when we take this field and we want to convert it to binary, we must separate it to two halves. This half will be converted to binary and combined with the other half that will be also converted to binary. Okay, so what will the switch do eventually? It will fill this field, the destination mark field, the unknown field, with all ones, and these all ones, if you convert it to the hexadecimal, they will become all F's, because F is the largest number in the hexadecimal. If you remember, it equals 15 as a decimal value. Okay, it will be all F's. So this is what will the switch generate and insert it in the destination MAC address. Okay, what will this lead to? Who is all F's? All F's, since it was generated from all ones, means everyone. Okay, this is called the broadcast behavior, the broadcast message behavior, or called the flooding. Okay, I hope you make some useful, okay, some use from this, because I will delete it. Okay, so this was called the broadcast behavior or flooding. The all F's means that when a switch, for any reason, when you hear MAC address flooding or broadcast message, you will know this thing, that in a switch, whenever a switch receives a frame from a port, maybe port number 1, okay, to an unknown destination, what will happen is that this frame will automatically be sent to all other ports except for the port that it did came from. This is a real switch. It has 4 ports. It did received a frame with an unknown destination in port 1. It will automatically forward it to all the other ports except for the port that it did received the frame from. Okay, this is the flooding behavior. This is the behavior or the reaction for the broadcast message. The broadcast message is the message that has a destination of all F's, which are in the binary language are all ones. After that, what will happen when it will be sent to all the computers? Okay, each one of them will reply to the switch. This is the very important steps of the flooding. What is the benefit of flooding? Okay, so you remember we said computer number 1 want to communicate, maybe computer number 4, which has no MAC address in the table. Okay, so the broadcast message will be sent to computer number 2, 3 and 4 automatically. Each one of them will reply. Okay, remember this. Each one of these 3 computers that received the broadcast frame will do a reply to the switch. This reply from each one of them will include its source MAC address. Each one of them will reply with a frame, and the frame must include a source MAC address. So computer number 2 will reply with its source MAC address, and this is already known, okay, because port number 2 has such MAC address. This is known to the switch. Port number 3, this one, okay, will reply with a frame that has a source MAC address of the PC number 3 MAC address. This is also known, but the unknown thing, the reason for all this mess, PC number 4 will automatically reply to the broadcast message with a frame that has the source of its MAC address, and by using the dynamic entry, this MAC address will be added in the fourth entry in here and be assigned to port number 04, and this is how the problem of the unknown MAC address got solved. Okay, so this is how we use, I'm sorry, this is how switches do use the flooding to solve the problem, or for every time that an unknown MAC address occurs. So flooding will happen. After flooding happens, the MAC address entry will be known and added to the MAC address table. Okay, you must note and know that broadcast is not something likely to switches. Broadcast message and all what happened right now of receiving an unknown destination frame flooded automatically to all the interfaces that on the network except for the interface that send the unknown frame. This process, after that receiving the MAC addresses, after that updating and refreshing my MAC address table to add the missing MAC addresses, this consumes CPU and consumes RAM. It does consumes a lot of the processor and the memory utilization. So it's not something likely to happen. It do happen sometime, yes, but if for some reasons that we will talk about in the upcoming subchapters of chapter 2, the flooding or the broadcast domain happened rapidly, this will cause the utilization of the processor and the memory to be increased. It might even reach 100%. This will crash and destroys your switch. Don't worry, switches do have a lot of mechanisms to protect themselves. We will talk about these mechanisms in the upcoming videos. Okay, thank you for watching. Please comment for any note about the material and the performance, and we will be more than glad to what do we call it, to upgrade our performance materials and to improve it. Okay, thank you.